Okay, we're going to talk about change in coordinates, directed distance. Okay, we've always said distance is a positive value, and it is, but right now we're going to talk about directed distance, which means when you want to describe a distance that is going from a larger number to a smaller number, you will use a negative sign in front of that distance you're talking about going a certain distance in a certain direction. So to indicate the direction you're going in, you will use a negative sign. So what kind of change do we have when we move from -7 to 3? All right, so if we start at -7 and we move to 3, we are moving 10 spaces in the positive direction. So it would be a change of +10. So how can we use those two numbers, -7 and 3, to show by subtraction that positive number? Well, if we wanted to show it as the positive number, we wouldn't say -7 minus 3. We would say 3 minus -7, which is 3 plus 7, which is 10. So when we're trying to show the directed distance, we start with the second number and subtract the first number. So when I say I'm going to go from -7 to 3, and I want to know, is that a positive change, a negative change? You take the second number and subtract the first number. All right, so how about if I go from 3 to -7? Well, I start here this time and go the other way. And I want to say that is a change of -10. And so we can write that by choosing the second number first this time. -7 minus 3 is what gives me the -10. Okay, now we're going to talk about a change in coordinates. So given the points, p sub 1 is equal to -3, 2, and p sub 2, -4, -5, what do we represent by -3 minus -4? Okay, well, those are the x coordinates of these 2 points, and you can see that we're going from -3, that comes first, and -4 comes second. So that means, remember, the first number comes second in the subtraction. So we're going from -4 to -3. So we would say that this is the change in the x coordinate as we go from P2 to P1. All right, what do we represent by -5 minus 2? All right, well, we're going to talk about the y coordinates now. And in the subtraction, the 2 comes second. And the -5 comes first. So the -5 has to be the second number. It's where we're going to. So now we're going from this point to this point. So this represents the change in the y coordinate. As we go from P1 to P2. And when we talk about a change in coordinate, you're going to see in the book they use delta C. Delta in math means change. So when you see delta C, it means the change in coordinates. And when you see C sub F minus C sub I, so sometimes they'll put delta C, the change in coordinates, is equal to the change in the final coordinate minus the change in the initial coordinate. So you start with the second coordinate first, and then you subtract the initial coordinate. All right, directed distance between two numbers. So what is the number that is 3/7 of the way from -4 to +10? All right, so we look at the words here. we want 3/7 of the way from -4 to +10. Well, the way from -4 to +10 means as you go from -4 to +10. All right, so remember, we start with the second number, so 10, and then we subtract the first number, so minus -4. This is the way from -4 to 10. We want 3/7 of that, so we're multiplying it by 3/7. So if you look at the picture, all right, the way from -4 to 10 is this long red arrow all the way from -4 to 10. You're moving 14 in the positive direction. And I broke that up into sevenths, 2 each. And so 3/7 of the way, 1, 2, 3, is right here. That's where you're going. If you go 3/7 of the way from -4 to 10, you end up at 2. So you got the way, 10 minus -4, you're multiplying that by 3/7. And then to figure out what number you're going to end up at, you start at 4, and then you add that 3/7 of the way to get there. So we're putting the -4 here, the number we start at, we add 3/7 of the way, and it ends us up where we would end up if we started at -4 and went 3/7 of the way. So let's look at one, and we just won't even draw a picture. We'll just say exactly what you do. So find the number that's 5/11 of the way from 3 1/8 to -3 5/8. All right, so again, if we're going to talk about the way from 3 1/8 to -3 5/8, then we are talking about subtracting the second number minus the first number. And then we want 5/11 of the way, so we're going to multiply that by 5/11. And then we are going to start at 3 1/8, because that's where we're going from. We're going to add 5/11 of the way, and we'll see where we end up. So that's the point of that question. Find the number you will end up at if you go 5/11 of the way from 3 1/8 to -3 5/8. So this part of the expression is the way from, is 5/11 of the way from 3 1/8 to -3 5/8. And this is where we're starting from, and then we're going to add that amount to it. So that's 3 1/8 plus 5/11 times -29/8 minus 25/8. So that is 25/8 plus 5/11 times -54/8. So that's 25/8 plus -270 over 88. And so that is 275 minus 270 over 88. So that is 5 over 88. Okay, the distance formula, you have learned this before, but we will just go through it again. How can you find the distance between the points 1, 3 and 7, 6 when it is a slanted line? So the point 1, 3, the point 7, 6, you can't tell how long it is just by looking at it. And so what you have to do is create a right triangle and use the Pythagorean theorem to figure out that hypotenuse. So you can figure out the lengths of these vertical and horizontal by just adding up the squares. So this vertical line is 1, 2, 3, and the horizontal line is 1, 2, 3, 4, 5, 6. And so when you use the Pythagorean theorem, 3 squared plus 6 squared is going to equal, well, I'll call it the distance, d. It's going to equal d squared. So 9 plus 36 is equal to d squared. So that is 45 is equal to d squared. So d is the square root of 45. So that's the distance between the point 1, 3 and the point 7, 6. This is not a directed distance. It's just the distance. It's the length of that hypotenuse. So we know that that's what we're doing. Basically, we are looking at the difference between the x coordinates, which tells you the length of this horizontal piece, and the difference of the y coordinates, which gives you that vertical piece. We're adding those, we're squaring those and adding them together, and then we're taking the square root. That's what happened. And that's where the distance formula comes from. So this is the distance formula. The distance between 2 points, x1, y1, and x2, y2. So the difference in the x's quantity squared plus the difference in the y's quantity squared, and then take the square root. And that's how you find the distance between any 2 points. So use the distance formula to find the distance between the 2 points for -2 and some other point, xy. So the distance is the square root of the difference in the x's, so 4 minus x, quantity squared, plus the difference in the y's, -2 minus y, quantity squared.